In the previous class, we have discussed about the behavioral modeling and how non-blocking statements are assigned and blocking statements. After that, some procedural timing, intra-delay, inter-delay, and event-based also. I told you that I forgot to ask you that event-based. When you are giving the event-based, all these things are also you can learn. Okay, in the event-based, triggered event and then named event also there. Okay, you need to listen that. And then today we will discuss about the if statements. What is that if statement? What is the use of if statement we are using? This slide will tells you all the content in the if statement. Same thing I have created in my own way. Okay, so you can refer this slide also, and then I will explain from this slide onwards. Okay, so what is if statement? What is the use of if statement? So if statement checks the condition. Okay, if the condition is true, okay, one statement is executed. That is the basic thing where we are following the if condition. Okay, so what is that if condition means? See, if condition. So that condition is maybe A greater than B, or A less than B, or A equal to B, or A greater than 100, or A less than 100. Any condition, you can consider. If the condition is true, this statement will be executed. Okay, otherwise skip for that and execute the another block. That means, so if you have only this is for used in large conditions. Suppose one condition is true, execute one statement. Otherwise, if it is going for the other statement. Okay, sometimes we have if else condition. If else condition means if condition is true, one statement is executed. That means if A greater than B, okay, A is greater than B, I will get the statement like max equal to A. That means A is the maximum value. If this condition fails, what it happens? Okay, if this condition is fails means I got that maximum value is B. That means the condition is A is greater than B. One person is higher than yours. Okay, that person gives you the highest value. That condition fails means other person will be taking place. See, one condition. Suppose my condition is called if else condition. If it is raining in the outside, I need to carry umbrella. Okay, or if it is sunny, so this condition is fails. Okay, fails means real condition. Then this sunny, then wear the sunglasses to protect your eyes. That is the if else condition. How if else condition will be taking place. So in the real time scenario, so you are seeing the green signal. Okay, green signal means you need to go. Okay, there is a green signal on the road. Then why we are waiting for that? So we are waiting for green signal. The green signal is already there. Then you can go. The condition is true. Otherwise, if green signal is not there, yellow signal is there means you need to control your speed. Okay, control your speed at the same time, and then within seconds you will get the red signal. Then you need to stop. So yellow signal and red signal. Yellow signal will gives you that okay. You need to wake up. So there is a red signal is going on in the future. Then I need to control my speed. Okay, that gives you the indication of yellow signal. Then if it is gone means then red signal will be there. You need to stop at that signal point. So that is the if else condition. Okay, so how this hardware also behave like this. Okay, one condition is true, then takes the true condition value. If condition is false, then takes the else condition. That is the if else condition. But if condition means if your this if condition is true only, then you can take the one value. Otherwise, it will goes to the other if statement. Like if how we are taking this means if A greater than B, then I need to if this condition is true, then I get the maximum value is A. And then if it is not true, then I go for the other condition B greater than C. So then I will get the max equal to B. If it is fails means another greater than another condition. If C greater than B, then I got the value max value like C. Clear. So here also we are considering the statements only, if statements only, not going to the else statement. If else statement, then you can go for the if else statement. One statement is true, then true statement will be this is the true statement and this is the false statement. Okay, clear.
Yes.
So then nested if conditions. When we go for the nested if conditions means, so if I want to execute multiple statements, so one condition is true, then go to the other condition, then other condition is also true, again go to the see one file inside the other folder, inside the other folder. So one folder you can find that, open that, again you can find the other folder, again you can open that folder means again you can find that another folder in that way. So nested if condition is true, okay, a greater than b, then if inside the another if, that is the nested if. So one condition is true, then I want to begin another condition. Okay, so this condition is true, this statement will be executed. Or if this condition is also false, again you can go to the another if condition, a greater than c. Okay, then I want to execute the output like a. Okay, in this way nested if conditions will be there. Sometimes you need to use begin end block. Why we are using the begin end block means I need to execute multiple statements. If condition is true, if this condition is true, then one statement I want to execute like statement 1 max equal to a. Okay, and same way in the statement 2, and then this valid value equal to 1, that means this condition is valid. Or another statement 3, okay, in this statement 3, this time my data should be equal to some 3 tick 3 tick binary 101. Okay, in that way I want to execute multiple statements. We need to use begin and end. In between the begin and all the statements are executed sequentially. All the statements are executed sequentially.
Sequentially.
Sequentially means one statement is executed, so go to the next statement 2. Okay, after that statement 3. Based on that, it will be considered. Okay, begin and in between the begin and multiple statements are used. And clear. See, this is the begin and statements example. If a greater than b, max equal to 1 and then flag equal to 1 or some full condition equal to 1. So based on that I will write many statements. And then sometimes we can also use always block for if condition. So this if always at the rate star, this is the RTL logic uses. Most of the cases we are using in the design side, behavioral modeling condition, we can use this design. See all these loops and then if else conditions, case statement, whatever you are using, all these comes under in terms of behavioral modeling. Okay, whatever the behavioral modeling you are considering, that will comes under all these things. See, always at the rate. So star you can represent means it will consider all the sensitivity list we can consider. Okay, whatever the sensitivity list you have in your design, all the sensitivity list will be considered here. If any value can take, any value can change, your input and output values are also changing. That means if a greater than b, my I will get a max equal to a. Or else condition, if you want to consider multiple if statements, else if you can take Okay, in that else if condition A is greater than C. If A is greater than C, I will get max value equal to A again. Or else condition, I will get the max value equal to C. In this way, we need to consider. And then other else statement like this else statement, and then else statement like I will get the max value like B. Okay. So this is the multiple if else conditions or nested if conditions. See, there are the unknown values and then high impedance values we are using in if else conditions. See, if you are considering 2 by 1 multiplexer, at that time I am giving some what it called select line, because this is my 2 by 1 marks. In this 2 by 1 marks I am taking two inputs A and B and one select line S. Okay, select line S. Okay, and I will get one output based on the select line. If select line is 0, I will get output is A. Okay, my output is connected to A. And if select line is 1, okay, I am considering my select line is 1, I will get the output B. Here my I am getting the output is called B. But if your select line is unknown or high impedance, what it will happens? Okay, simulator is choosing that unexpected path. That means you're maybe getting some unpredicted output at that time. See, unknown values can create unpredictable simulation result. Okay, that time we can get some bugs, some hidden bugs will be getting. Okay, so at the time this is the dangerous thing while you are using if condition. At the time you are giving the input like unknown value or high impedance value, your simulator what type of output gives you we don't know, because that is the unexpected path we are getting. That time what we don't know about the simulator behavior. Okay, and these are the common usages of if else statements where we are using some decision making, like if SDA equal to 1, that means some condition I am maintaining. Or if SCL equal to 1, okay, some condition I am taking. Or if condition A greater than some 100, okay, based on that up to the greater than 100 values we can consider it. This type of decision making condition we are using if condition. And also FSM control. FSM control means I am taking current state and then next state. Based on this I am going to execute the my final state mission FSM I will execute. So this FSM having some conditions like idle condition and then start condition and then some address phase or some acknowledgement phase, and in this way we have some state missions. So this state mission, first I want to give that idle condition. This idle condition is true, then go to the next state is called start state. My next state is start. If this condition is also true, then if it is in start condition, then the next state is going to address state. In this way, my values will be changing. That is the FSM control also we are using. Most of the cases reset logic we are using. That means if my this is not reset means this is active low reset. Active low reset. In this condition, in this active low reset condition, if you are giving value should be 0, then my condition is true. This condition is true means whatever the values you have, like data and then address and some flags, whatever the values you have, all the values should be initialized to 0. All the values should be initialized to 0 during reset condition. that is accepting reset condition. Okay, you are accepting reset condition. During reset condition, all my value should be initialized to 0. This is an active low reset. This active low reset will be operated on logic 0. Okay, when you are operating means you are giving logic 0, then your reset will be on. At that time, all my values should be initialized to 0. If it is releasing means you are operating on logic 1. High logic you are operating, then this condition is false. False statement will be executed. Some ALU operations like addition, subtraction, like your opcode may be some result or some output I'm mentioning, that should be equal to subtraction operation I'm applying. And then my result should be equal to multiplication operator. Okay, this type of conditions we are using if else condition. This comparator statement regular usage only. I told you many times in this if condition statement. What are the common mistakes we are doing? Else condition sometimes we are missing. If else condition you are writing, then else condition we are not writing. But it can infer that unwanted latch. So you are not writing means else condition, not a problem, it will be treated as a latch condition. But I don't know which type of latch is considered. Okay, that gives you the some bug. And then begin end condition, like if you are going for multiple if else condition a greater than b, then in between the begin end you are using multiple statements. Don't skip this begin and end, because if you miss this begin end means whatever the first statement is there, that statement only executed, and the remaining statements, whatever the remaining statement 2 3 are there, means these are not executed in your simulation. That is the problem. Only first statement is controlled. The remaining statement I don't know what it happens. And then deep nested ifs. So if you want to make RTLs hard to find debug, so then you can don't use that deep hard whatever if else condition, like if condition and then another if condition, again another if condition. So don't use all these things and try to ignore most of the times unknown values and high impedance values in your if else statements, because simulator is unexpectedly taking some other values. Okay, that gives you an error. Okay, and then comparing between the if else condition and then case statement, if gives you more priority. Whatever the statement is true, that statement equations only executing first. That gives you the most priority. That means whatever the statement is true, that statement only gives you the most priority. And then case statement, if you are considering multiple equations, like one value you are giving, like suppose I am taking one case statement. Next slide I will explain the case equation. Suppose case select line I am considering. Suppose 4 by 1 mux you are considered means, so two select lines are there, S0 and S1. That means 0 0 0 1 1 0 1 1. Four conditions are there, right? All the four conditions like 0th case, your output should be I naught, and then one case your output should be I1, and then two case your output should be I2, and then third case your output should be Y3. Okay, so single case statement you can select multiple values. That is the use of case statement. In the if statement, if condition is true, only one value you can consider, but most priority is there. Okay. See, that is the if else condition and then case statement difference. See, this is the condition is true, y equal to a execute or y equal to b execute. This is the 2 by 1 multiplexer. So easy to reminder. So if condition, that is a decision making. Whatever the decision making, if condition you are taking, this is called as decision. Okay, this decision is true, then you can go to that. And else condition means that is an alternate path. That means your condition is true, then you can have alternate path. Plan A fails, and then go for the plan B. And if else condition means not only plan A and plan B, you have multiple plans. Okay, that is the if else condition statement you can use. And nested if means one decision inside the another decision. That means your decision is not final. You need to decide first what is correct, what is false, and again you can ask your parents. Then again your parents are also asking another friends, and their friends are also referring to the some other experienced guys. So in this way, this nested if will be executing. Clear? So this is the summary. You can read these points once.
The statement in Verilog is a conditional decision-making construct used to control hardware behavior based on logical conditions.
Okay, if statement is based on the decision making, right? Decision making construct. Most of the cases we are used in behavioral modeling of hardware design. Okay, that is the one statement. And the next statement, it evaluates the expression and executes specific blocks. Okay, if condition is true, allowing that designer model to be comparator. So if design is true, if condition is true, then you can allow that. Like you can build multiplexer, demultiplexer, and final state missions and reset conditions. All these conditions you can go for that. And if else statement. So this structure selects that what it is selecting that some alternate paths, like one path is fails, then you can go for the alternate path. And then nested if else conditions. What is the use of that? You can handle multiple if else statements or complex decisions. You can go for that. So in synthesis, most of the commonly used hardware is called as if statements only. And then such why we are going for that means you can use the comparators and multiplexers and making them one important construct in your design modeling, that is the if statement. Okay, this is the summary of if statement. Same case statement, you can refer this slide for entire data. So once you can ready a study, so in your free time you can zoom it out and then check the codes related to the case statement and also go through the points. So case statement compares the expressions, like case statement is a multi-way selector. Okay, in multi-way selector means one expression. If you are giving the one expression, I am getting multiple. I am taking the multiple statement like value 1, value 2, value 3, and we have default statement also. Without default means it will get some errors. Okay, so if you are not considering, like, that means you are not checking any condition, that will be treated as a default condition. Okay, some hidden see at that time you can also not considering the default statements, not a problem. Your code coverage may be somewhat less. Okay, so that default conditions are not considering while simulating, and then we are considering, we are checking the code coverage statements. Okay, here also same. It checks the expression, whatever the expression you have, some value you are giving or select signal you can give, or some condition you are giving. Okay, a greater than 10 you can give. Based on that, it will be checking the expression. And not only single value, you can take the multiple values. In that, one matching value will be appeared. Clear? One matching value will be appeared. What is the case statement? Case statement is used to compare values. Okay, most of the times we are using the comparing purpose. The cursor. Okay, most of the time we can use the case statement like a comparison purpose, like one expression against that multiple possible values we are considering. That means one match occurs, that when a match occurs, corresponding statement is executed. Like, see example, the data you are giving. In this data, 2 you are giving and 4, 5. So multiple values you are giving. I am executing one value. Suppose if my is equals to data is equals to some 3 tick H2. Okay, hexadecimal 2. So at that time, this statement will be matching. Similarly, you are considering the select line. In this select line, I'm having four conditions: 0, 0, 0, 1, 1, 0, and 1, 1. Okay, for 0, 0, I'm giving this value will be selected, and one value 1, 1, I'm giving y3 value will be selecting. Okay, so you are giving only single select line, but you are selecting multiple statements. That is the case statement. And in case statement, we have another cases like casex and casez. This is the normal case. And then here also we can go for the multiple case statements, like multiple statements you want to execute it. We can go for the begin and cases. Okay, begin and end. If you want to execute multiple case statements, so inside that begin and we can go for that. Okay, one for single case, for 2 tick 0, 0 case, I want to give two values. Like 0, 0 case, y value, I naught value I am getting, and also some valid value also I am getting. In this way, I go for 2 tick 1, 0. Okay, 2 tick B10 case. In this case also I am begin and using this condition. My data output should be I1 will be executing, and then some other data also I'm giving, like data equal to 4 tick binary 1010 I'm giving, and also data I'm giving, so 4 tick, sorry, address I'm giving 4 tick B1101. In this way, multiple statements you want to execute inside the case statement, go for the begin and end. In between the begin and you can write how many statements you want to write, you can write. Clear? But case x, this gives you that if you are taking x value or z value, it will be considered as an unknown value only. Okay,
Yes, sir.
always treat it as a don't care value only. See, why we are don't go for the casex means it gives you the hidden bugs. Okay, so some bugs will be hide because it will matches accidentally. Like how it is matching means you are giving one x or one z. That means this time it will take either 10 or 11, and here also you will consider either 10 or 11, or sometimes 0z you can take. That means 00 you can take, or 01 you can consider. That means any value will be matching. That gives you the problem while identifying that which statement is executing first. Okay, so that case statement will gives you some problem. And compared to the case x and case z is go for that preferred over that case z. Why this case z means this wildcard thinking will be taking place. Wildcard thinking means question mark will gives you that. This question mark gives you either 0 value or 1 value you can consider. Okay, so similarly, don't care value like, but this cannot comparing that x value. Okay, this x value will be 0 or 1, and don't consider that. Okay, so this value will be considering either 0 or 1, depends upon the decision which I want to consider. Based on the decision, it will be prefer that case z value. Okay, so here just case x and case values, why we go for that means unknown value and high impedance values are also we are preferring. That
Yes,
is the
sir.
purpose we are taking that case x value and case z value. Okay, see where you are using these case statements means, So in the real world, like we are using case statement like some final statements you want to execute it. See, I want to considering one handle. Suppose I'm using some type def. So this is my type def. In this, I'm taking that idle condition and then wait condition and then start done. I'm taking four condition. For this, I'm considering one handle like this handle will calls you all these values. So at this time, the position values will be assigning automatically zeroth position, first position, and second position and third position. These positions will be assigning automatically. So this handle is called as state. Okay, I'm taking this state. This state is 0, idle condition will be executing. This state is 1, wait condition is executing. This state is 2, done condition is executing. And this state is 3, start condition will be executing. Based on this case statement, single value are selecting, and I'm considering multiple values. Okay, single statement, single expression you are considering that. Based on that, I'm considering multiple values. Okay, so where we are using the common usage of case statement is multiplexer times and final statements and decoding of opcodes like encoder, decoder. Okay, all these things having multiple values, right? So suppose decoder is there, 3 by 8 decoder is there, 8 values will be there. Okay, 3 inputs means 8 values will be considered, right? For zeroth value, one output I am getting. My output value will be 0, 0, 0, 0, 0, 0, 1. This value I am getting. And then for one case, and then 0, 0, 1 case, I am getting the output like 0, 0, 0, 0, 0, 0, 1, 0. Am I getting? So this value D0, this is D1, D2, D3, D4, D5, D6, D7. In this way, one value I am getting at a time. At that time, I can go for that case statement. See, why we are going for casex statement means this can hide unknown state bugs. Okay, suppose you don't know some unknown steps, so that can hide you. Okay, that's why don't use casex and casez. Okay, you can use casex wisely. Okay, and then overlapping conditions that gives you some ambiguity, like some confusion with you will get. And then don't go for multiple statements without begin end. If you are using multiple statement means you need to use begin and end statements. Within the begin end only we go for the multiple statements. Clear?
Yes, sir.
So same summary is there. Okay, case statement where we are going for multi-way decision purpose, we are going for the case statement. And used in comparing one expression and multiple possible values will be executing. Okay, and execute matching block of the statement. One value is matching means that value will be executing. And it behaves like a hardware selector, like so widely implemented in multiplexers and finite state machines, of course, all these things. Okay, where we are using all these statements are mentioning. And then normal case statements is like a exact matching. And then while go for the case x and case z, which will gives you that wildcard matching. That means some unknown values and high impedance values are also matching means, so you will get some unknown path. And during synthesis, you can convert into your efficient combinational logic circuit like muxes and then decision maker, decoders and then encoders. We can go for the case statements. Okay, making one of the most important RTL to construct your digital hardware design. Like case statement, you can design that. Okay, so you can use the case statement. You can design important RTL likes. Okay, this type of constructs you can use. Okay, whatever the digital hardware you are designing, this type case X, case Z, case statements you can use.
Yes,
Loops. Loops are used for, see, I'm repeatedly doing the same same work, then I can go for the loop condition. Suppose I want to give you some instructions today morning. You need to listen this video and then come for the class. So daily I'm repeating this word means so I'm in loop. Or every one robot is there, that robot want to execute same task every day, so then that robot is in loop condition. Okay, so at that time we are using the loops, for loop, while loop, forever loop, and then for repeat loop we have. Okay, what is the use of for loop? I told you repeatedly you can execute one condition, then go for the for loop. Okay, for loop is a control structure that repeatedly execute code based on your condition. You are giving some condition and then some repetition type or forever you can use. Okay, so most of the times you are giving the condition like initializing, you are taking that I equal to 0 and then I less than some 100. That means based on that I equal to 0 up to 100 times I am repeating this statement only, statement 1, statement 2, these statements only I am executing. Suppose you are going for some and condition and operation you want to execute it. Suppose I equal to 0 and then I want to execute my and condition 10 times and incrementing the loop, and I am executing my output y of I equal to a of I and b of I. Okay, so why I am considering I here? These I values will be taking place. That means y of 0 equal to a of 0 and b of 0, or and sometimes y of 1 equal to a of 1 and b of 1. Okay, up to this I value is reaches to 10, then your loop will be executing at the 10 value, your loop will be terminated. That means 0 to 9 values it will be considering at whenever you are reaching the 10th position, your loop will be terminated. That is the purpose we are using for loop. Okay, for loop, why we are going for the for loop means if you want to know how many times it is repeating, you can know the number of iteration, then go for the for loop. Clear? And while loop, it is also a known condition only, but it is repeating whenever the condition is true. Okay, if the condition is false, it is terminating the loop. Same thing, but repeat until the condition becomes false. So not repeating infinite times. Suppose while I greater than 0, you can take. This will be executing infinite time because 0 greater than 1. So 1 is greater than 0. Then condition is true. 100 is greater than 0. Condition is true.
Yes, sir.
So this is infinite times it will execute. But while I less than 10, that means I equal to 9, up to this it will be executing. Whenever 10 reaches 10 less than 10, condition is false. Not executing. Forever loop. This will be executing infinite times. I told you example related to always some 5 nanoseconds, clock equal to negation of clock. Okay, this is my clock generation. This always will be repeating infinite times but regular intervals of time. Similarly, forever also is executing infinite time. Forever hash 5 and then clock equal to negation of clock.
That's the
Okay?
delay.
Huh?
5 seconds of delay.
5 seconds delay will be there. That 5 seconds delay means your clock will be starting from 0 and ends at 5. That is the positive cycle, and then negative cycle, your 5 to 10 again 0. Every 5 seconds it will be toggling your clock. Repeat loop. How many times you want to repeat the loop? So then Fixed number of times I want to repeat my conditions, then go for the repeat loop. Okay, so you are using the repetition. Repeat means, so I want to repeat 10 times or 20 times. I want to execute my condition 10 times. Go for the repeat 10 times. Or I want to execute my simulation like 20 times. While when you are using means, if you are randomizing the values, at that time this repeat condition will be used. Suppose I want to give some random values, but that random values in the range of 1 to 10. But at that time I want to repeat my statement 1 to 10 times. Okay. So why we go for the loops? Loops will reduce the repetition of code, but it is hard to understand. So that's why designer don't go for the loops because understanding is little bit hard. Okay, while designing that large hardwares, then go for the loops because sometimes I need to repeat my code 10 times. At that time, this loop will be helpful. Why these loops are used means it will gives you cleaner statements and then smaller statements are writing and easier to maintain. So easy to understand the code. So that is the loop's purpose we are considering. So for loop, most of the things I have explained here. Okay, for loop is that commonly used for repeating different times, number of times. See here for initialization is there, condition is there, and update is there. See, if you are using for loop like this, you need to use integer. I told you in data types in integer I you can use. This integer I will initiate whatever the for loop value you are using that purpose. See, counting purpose we are using that is integer. Okay, if you are not using this integer, then for int I equal to 0 and I less than 5 and I plus plus in this way also you can use. This integer, this int represents this value, integer I. So initialization I equal to 0, condition I greater than 10, and loop increment I equal to I plus 1 or I plus plus you can also increment. These are the examples for the for loop condition. Okay, I told you. So some and condition I am explaining here. Y of I equal to A of I and B of I. Okay, so these many times, so 4 times it will be executing. Clear? And then while loop, repeat while condition remains true. If your condition is true, up to that it will be executing. While condition and begin number of statements you can write. If condition is fails, it is executing exit from the loop. If false condition, so never use becomes to false condition because it is in the infinite loop. Okay, infinite loop means your simulation may be hands. Your simulation will be in deadlock condition. Okay, not come out from that simulation. Okay, don't use this while one. Sometimes they will ask you try to generate the clock without using forever and always because you're using that always some 5 nanoseconds your clock equal to negation of clock. This is your clock generation, right? And similarly you also used forever some 5 nanoseconds your clock equal to negation of clock. Okay, so that is also you are using, but this is infinite loops. They are asking don't use these infinite loops forever and always. At that time you can go for while one. While one is also infinite loop begin and in between the end I am using that clock equal to 0 after 5 seconds I am going for my clock equal to 1. Okay, this value will be repeating up to the infinite time because this while one never comes end. Okay, at that time you can use. Remember, while one is used for infinite loops. Okay, forever loop. Forever loop. It is also repeat infinitely. Okay, but there is a condition like some forever loop we can use that when you are ending your forever loop means you are using dollar finish.
Yes, sir.
If you are using dollar finish based on the time delay, it will be terminating your loop. Okay, so forever loop is stopping purpose. We are using dollar finish, or you can use some disable condition. Disable also you can use. Okay, so this forever loop I told you repeatedly infinite times I'm using, right? And then see this is the clock generation hash 5 clock equal to negation of clock. This is the example for forever loop. See, don't use this type of blocking assignments without any delay while using forever loop. If you are using forever loop, A equal to B means you are assigning means your simulation is stuck at T equal to 0 only because it is having no delay. So if you are using delay or 10 and then 20, after that you can go for the dollar finish. In this dollar finish, you can assign some delay. 100 means this 100 time units it will be repeating. But this no delay statement A equal to B, some X equal to Y or Y equal to A and B, in these statements you are assigning inside the forever loop means, so there is no delay, then this will be executing at time t equal to 0, this will be executing at time t equal to 0, this is also executing at time t equal to 0. Then your simulation is stuck at time t equal to 0 only. Okay, don't use this. If you want to stop that simulation, then go for the dollar finish. Dollar finish is the one statement you are in what it called. You are exit from the forever loop condition. And then repeat loop. What is the use of repeat loop? I told you that repeat fixed number of times you want to repeat your statement, then go for the repeat. See repeat how many times you want to repeat. 10 times I want to repeat. Okay, this hello world, hello is the display statement I want to repeat 5 times or 100 times or some 200 times based on that your repeat condition it will be printing. Okay, so this repeat is automatically incrementing, counting is automatically incrementing. Okay, don't use any loops for a counting purpose. Okay, no need for loop variables here. Just it is repeat is the condition, repeat 5 times or repeat some 10 times, this will be enough. Clear? These are the loops we are using where for loops are used. Arrays concept we are using for loop, or sometimes I need to count my simulations. At that time also you can use for loop, and so counters times you can use for loop. So or you can also use while loop here. Okay, while loop for counting purposes, arrays purpose, while for loop you can use, and then clock generation purpose forever loop I am using, and memory initialization or repeat sometimes I can use repeat.
Yes, sir.
Okay, so this is the most of the cases are used in test bench purposes only. So because we need to repeat sometimes, so that is the test bench purposes or FSM iteration purposes we are using the loops which are synthesizable. For loop is synthesizable, but sometimes we can go for your design side. But try to, as a good design and verification engineer, don't use loops. And repeat loop, it is also sensitizable, but most of the times we are used in our test bench side. Forever loop, almostly most of the times in test bench only. Don't use in the. This is also mostly sensitizable. Okay, and infinite loop not sensitizable. While loop is not sensitizable because don't use that while loop in your design code. I told you for loop is for counting repetitions, while loop for conditions, and then forever loop for infinite loop, and repeat for the fixed number of iterations. Okay, so fixed number of repetitions we can go for that repeat. So this is the summary you can study. So repeat loop executes different block times. For loop is number of iteration times it can be executed. Use it for number of iterations times. And while loop for until the condition becomes false, it will be repeat. And forever loop it runs infinitely. For clock generation purpose we are using. And then repeat loop is execute fixed number of times. Most of the designers we are using these repeat loop, parallel loops, all these things. So execute sequentially. Whatever the loops we are using means all the statements are executing in the sequential way. Okay. Most of the loops are used in arrays, counters, memories, and FSM clock generation. All these things are used in verification environment. Most of the times we are using the verification environment. Okay. So these are the sequential and parallel blocks. Okay. Why we are naming the blocks? So I need to know which group of statements are executing. So that purpose we go for the blocks. And then sequential and parallel, I told you sequential means one by one statements are executed. Parallel means at a time all the statements are executing. Why we go for the named means which block I want to execute it. So because while going for the complex designs, we go for the names. We go for the blocks by names. Okay, and also disable statements if you want to go if you want to execute from that statement, exit from the statement, you can use the disable statements. What is a Verilog block? Okay, Verilog block is a group of state, it is having the group of statements, it will be treated as a one block. One community is there, in that community group of people are sitting, that is called as a Verilog block.
Yes,
Okay, so a group of people are sitting in a one place, that is a forming a one community. So that is also a block. Okay, instead of writing separate statements independently, you can go for the blocks. Okay, so one statement, two statement, three statements you are executing. So then go for the blocks. It will be organize them and together. So that means one statement, second statement, third statement. All the statements are inside the block. Okay, suppose I'm executing some CSR block, some I2C block, some APB block, some AXI block. Name that. AXI, what is that? CSR, what is that? So name that block and then write some group of statements and call that block by name. That is the use of Verilog block we are using. I told you sequential executes one statement after the another. One statement is executed, after that another statement is executed. Parallel block means execute simultaneously. Okay, so see in between the begin end, all the statements are executed sequentially, and then in between the fork and join, all the statements are executed at t equal to 0 only. At time t equal to 0 only, it is executed, but depends upon their delay, it will be executing their delay time. Okay, see here statement 1, statement 2. See, this statement will be executing at t equal to 0, and this statement is also executing at t equal to 0, and this statement is executed at t equal to 4 because here I mentioned the delay. 4 is the delay. See, all the begin end statements are also executed time t equal to 0, but there is a delays, but one statement is executed. If you have any delay, this delay will be added here. Okay, first delay I equal to 3 is there, I am having the delay 1, and then I equal to 2, I am having the delay 2, then this 2 will be added to the previous delay, then it is executing at the time delay at 3, and you're having 4, then all the statements are executed at 7 nanoseconds. This will be executed at 2 1, this will be 2, this will be 4. Okay, all the times are added, then you can know that which time delay it will be executed. But in 4 join, not like that. Okay, all the statements are executed at 5 seconds delay, whatever the last delay is there, at that delay only the final one. Okay, this will be executed at t equal to 0, this will be executed at t equal to 2, and this is executed at t equal to 5. Your final delay is the 5 only.
Yes.
Okay, whatever the highest delay is there, that delay is the final one. In named blocks I told you, right? So begin some statement you are writing, see sequential block I am executing, sequence block, so that is begin sequence block, and then end, you can end your block, sequence block, see. So this is the sequence block is ending. The name of statement, so suppose I am using begin and then executing I2C, I2C clock. Okay, that clock I am executing. Number of statements you can write. And while ending the statement, you can use this I2C SCL. Okay, you can end the block. And similarly, disable block. You can use it to stop the execution by name of the block. Okay, disable block, you can disable count loops. Whatever the count loops you are using, that will be disabled. So then here count is there, right? That count loop I want to exit. Okay, I want to stop that simulation. At that time, you can use the disable. So the loop terminates instantly. Whatever the loop you are using, that will be terminate instantly. Okay, what are synthesizable and what are not synthesizable? Begin end. Always we are using in state like design side, but sometimes we can go for that. See, it is synthesizable. Begin end is a synthesizable. Fork join, most of the times it's not synthesizable. Okay, because we are using in testbench side, multiple statements I want to execute it, so then go for the fork join. Okay, disable float, that is also in the testbench side, not synthesizable. Always synthesizable. Okay, named blocks, some limited things only we are going for. Some names you can go for, that is synthesizable, but sometimes you can go for the names. Synthesizable means it will generate that particular combination circuits or sequential circuit. Some gates will be generated. If it is not synthesizable, means your simulation not getting any gates. Some unwanted latches or buffers are replacing at that time. That means your behavior may be changing. That's why our design most of the times should be synthesizable. Okay, so I'm stopping up to this. Okay, so then tomorrow we will discuss this switch level modeling. Try to study all the behavioral modeling, data flow modeling, all these things.